Hello everyone, greetings from VNR JYOTHI Institute of Engineering and Technology. This is Manohar Reddy, Department of Cyber Security, Data Science and AIDS. Today in this session I am going to discuss about the disk scheduling algorithms. So disk scheduling algorithms. What is meant by disk scheduling and why it is important and what are the factors that to be considered for disk scheduling process. We are going to explain all this in this session. So disk scheduling algorithms. So first of all, disk means hard disk. We can able to tell that disk is nothing but hard disk. So why we are going to take that hard disk? Hard disk is for storage purpose, right? So we are going to store all the data, all the files, all the directories in the disk. So whenever you want to perform the read and write operations, that means when you want to read the data from the disk or write the data into the disk, we have to understand the seek time of the data reading and writing operations. So to understand that reading and writing operations, we have to use these disk scheduling algorithms. So here the disk scheduling algorithms in OS manages input output requests to the disk. That means each and every input request and output request. That is nothing but read or write operations to the disk and read or write operations from the disk. So the main motive is what? To minimize the seek time. Minimize the seek time. So seek time is nothing but the searching time or moment of the time. Moment of time. The disk arm contains the disk head, and that disk head processes the moment for the read and write operations. So how it moves, at what time it moves, and how much time it moves to trace the read or write operations. So that is what the seek time. So the main thing is what? To minimize the seek time and maximize the throughput. Maximize the throughput. So how we are going to utilizing the memory for the processes? Here the same thing, the disk utilization is important. So during this disk utilization process, we are going to minimize the seek time and maximize the throughput. These two optimize the order of pending requests to reduce the disk arm movement. To order or pending the request to the disk arm movement. So whenever the disk is moved, disk arm is moved to the performing read and write operations, there may be some pending requests are there. So to optimize that all, the order of pending requests to reduce them, the disk arm movement is important. This disk arm movement is able to finding the seek time. The disk arm movement is able to finding the seek time. So we have to minimize that seek time and maximize the throughput through this process. So operating system to decide the order in which disk IO requests, input output requests are serviced. So always it is using for the service for the read or write operations. The main goal is to reduce seek time, improve performance and increase throughput also. So for this purpose, disk scheduling is also known as IO scheduling. So it always giving the services for the IO requests. It always giving the services for the IO requests. So because of that, the disk scheduling is also known as IO scheduling. The main goals of disk scheduling are to optimize the performance of disk operations. So the disk operations are nothing but read or write operations. Read or write operations, and reduce the time it takes to access the data and improves overall system efficiently. So whenever you want to load a particular file, it takes some time to loading the file, right? So automatically, similarly, if you want to read a file from the disk, it takes some time. Similarly, if you want to write a file into the disk, automatically it takes a time. So we have to reduce the time. The disk scheduling process is important for to reducing the time, reducing that loading time, reducing that reading time, reducing that writing time. So it takes to access the data, and by reducing all these, we can able to tell that improving overall system efficiency. Overall system efficiency. So to do this process, actually so many disk scheduling algorithms, disk scheduling methods have been implemented. So out of that all, the FCFS, first come first serve is one, shortest seek time is second one, and the scan algorithm, C scan algorithm, and look algorithm, and C look algorithm. These are all the overheaded of the algorithms that are very important algorithms out of all these disk scheduling algorithms. So let us will discuss one by one. So before that, what are the goals of disk scheduling algorithms? So the main thing is what? To minimize the seek time, minimizing the seek time, and maximizing the throughput. So maximizing the throughput, by minimizing the seek time, automatically we can able to tell that the maximizing the throughput. So minimize the latency. So how much time it takes to loading, how much time it takes to reading, how much time it takes to writing is what? Minimizing the latency. And ensuring fairness, it always identifies the particular disk and ensure that each and every disk will be loaded to perform the read and write operations. So that means ensure that fairness is clear. And efficiency in resource utilization, particular depending upon the particular data, we have to utilize the particular disk data, disk formats, disk partitions. Otherwise we cannot able to use all the disk allocated memory, right? So for this, the disk scheduling algorithms, there are several algorithms. Out of all, the most popular are first come first serve, FCFS is the first one, and the second one is what? Shortest seek time first, and third one is what? Scan algorithm, and fourth one is what? C scan algorithm, that is nothing but circular scan algorithm, and fifth one is look algorithm, and sixth one C look, that means circular look algorithms. So all these algorithms are able to finding the disk arm movements, that is nothing but finding the seek time, the how many number of disk positions have been moved, how many number of disk arms have been moved. So depending upon that movements, all disk head movements, we can able to find the seek time, So let us discuss one by one. The first one is what? First come first serve. So in this diagram we are going to show the movement of the disk, movement of the requests, order of the request, how it is moving to the next position and performing the read or write operation, right? So here in this first come first serve, it is the simplest of all disk scheduling algorithms. So first thing is what? It is the simple disk scheduling algorithm in which FCFS, the requests are addressed in the order they arrive in the disk queue. So how they are arrived in the disk? So in that manner they are ordered, in that manner they are addressed. So let us understand this with the help of an example. So first, initially we have to draw the number of disk requests, number of order of requests. We have to draw like a table or chart. So 0, 16. So if you see the order of requests here, 82, 170, 43, 140, 24, 16, 190. These are all the order of requests. These are all the input output order of requests. And the current position, disk position of reader writer head is what? 50. At the 50th position, that is ready to take all the orders and perform the overhead movement. So how it performs? So for this purpose, what we have to do? First step, we have to draw this diagram. First step is what? We have to draw this diagram. So here the 0, 16 is there, so 16 we have to write, 24 is there, we have to write, 43 is there, we have to write, 50 is there, we have to write, because 50 is the head position. And the next 82 is also from this order of request, and 100 is one of the position, and 140 is the request, and 150 and 170, 190, all these are all order of requests that we have mentioned. So for easy purpose, we have to mention 0, 100 and 150. These are all also we have to mention. So now the order of request, how it has been moved. So if you see the first come first serve, as it is the first come first serve, it starts movement from the disk position, disk current position, it has to move. So how it moves? As it is the first come first serve order, the first order is what? First order request is what? 82. So it moves from 50 to 82, because that is the first one. And the next 170 is the second one. So from 82 it has been moved to the 170. So number of positions that have been moved, 1. This is the second position, second movement. And next 143 is the third moment. So from 172 43, the third moment, and similarly 170 to 43, 43 to 140, 43 to 140 is the fourth moment. So 43 to 140 is the fourth moment, and then next 140 to 24 is the another moment. So 142 another 24 is another moment, that is the fifth moment. And then next 24 to 16 is the another moment, that is the sixth moment. And then next 16 to 190 that is the seventh moment. So total 7 movements, 7 disk overhead movements have happened. So total 7 disk overhead movements are happened. So for this all the 7 movements, we have to calculate seek time. Total overhead time equals to the difference between the two movements, that is the difference between starting to ending, like that we can add all the differences into the total overhead movement. So how it will be added? So if you see 50 to 82, first one, so 82 minus 50, the next 170 to 82, so 170 to 82, that will be added. The next 170 to 43, so 170 to 43 is added. The next 140 to 43, so 140 to 43 added. The next 140 to 42, 24, that we have to add. The next 24 to 16, added. The next 190 to 16 will be added. So after sum of all these differences will be calculated as a total overhead movement. That is the 642. Total overhead moment, that is the 642. So based on this value, we are going to tell that the disk is utilizing properly or not, and the disk efficiency, system performance is efficiency evaluated or not. So like the way in the first come first serve, all the requests have been movemented from disk position. All the order of requests have been movemented from current position of the disk position, read or write head, right? So this is the way we have to calculate the overall total overhead movement. Right? So advantages of this first come first serve is, here some of the advantages first come first serve are: every request gets a fair chance. So every request from the order of request get a fair chance, and no indefinite postponement. So there is no postponement for the movements. So continuously it is moving from the starting to next one, next to next one. And what are the disadvantage? So it does not try to optimize seek time. We cannot able to reduce the seek time here. We can calculate the total overhead moment by differentiating by sum of all the differentiation of the first and second movements. And it may not provide the best possible service also. It may not. We can't say that it does not provide the best possible service. We can say that it may not provide the best possible service. That is the first come first serve scheduling. And the second one is what? Shortest seek time first. In shortest seek time first, the requests having the shortest seek time are executed first. The first come first serve order of requests will be in the first come first serve manner. So whichever the order of requests come first, that will be moved from the disk current position to next position. But in this shortest seek time, out of all the order of request, which is the shortest seek time, that will be executed first. So the seek time of every request is calculated in advance in the queue, and then they are scheduled according to their calculated seek time. Right? So the seek time of every request is calculated in advance in the queue, and they are scheduled according to their calculated seek time. So as a result, the request near the disk arm will get executed first. So as per this result, the request near the disk arm will get executed first. And this SSTF shortest seek time certainly an improvement over FCFS, as it is decreases the average response time and increases the throughput of the system. So it is comparably somewhat better than that FCFS because it decreases the average response time and increases the throughput time. And let us understand this with the help of an example. Let us see here. So if you see, all the disk order of requests are 82, 170, 43, 140, 24, 16, 190, and the current position is what? 50. So as it is, we have to draw the step 1, we have to draw the disk order of requests with the position of current position. So once it is started, so in the shortest seek time, the name itself shortest seek time, the order of request which is the seek time is less, that will be executed, that will be moved faster. So if you see, the current position is what? 50, and from that 50 which is nearer, which is less seek time of this 50, means 43 is the shortest seek time compared with the 50. So it has been moved from 50 to 43. It has been moved from 50 to 43. So this is the first movement. The next after 43 which is nearer to that one. So which is nearer to means 24 is the nearer. So we have to move forward to the 24. So this is the second position. The next 24 to 16. So 16, if you can compare each one you can compare, so that by comparing all these you can observe that which is the seek time is less, which is having very shortest seek time. So now according to that, the 16 is having the less seek time, so it has been moved to the 16, that is third position. And from 16 to the next one is what? From 16 to 82 is the next position, so fourth position. And from here 82, and after that 82 to 140, so this is the fifth position. So here 140, after 140 it has been moved to the 170, so it is the sixth position, 170, and from 172 remaining last 190, that is the seventh position, 190. So like the way the each and every position has been moved from starting to next basis on the basis of shortest seek time of the order of request. So this is the shortest seek time first. So you can see the advantages and disadvantages. The average response time also decreases. So compare with this one, it is a 642, and compare with this it is 208. So it decreases, the average response time is decreases, and throughput also increases. The disadvantage is overhead to calculate seek time in advance, and it can cause starvation for a request if it has a higher seek time as compared to incoming requests. So obviously if higher seek time order of request is there, it has to wait. So that is one type of starvation occurs. And the high variance of response time, as SSTF favors only some sort of requests only some sort of requests. So these are all the advantages and disadvantages of shortest seek time first. So these are the two first come first serve and shortest seek time first or disk scheduling algorithms, which tells that the response time increases and what algorithm is response time decreases. So I hope all of you understand, and use the below links for more data on disk scheduling algorithms for FCFS as well as SSTF. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.